Do you feel the vibes?
Hey guys, so we're going to continue 10.2 and move on to 10.3 today. So we learned how to convert between radian and degrees last time. And now let's talk about patterns, right, of these angles. Okay, so what we learned was that 180 was the same as pi. And now if I have an angle in radian of pi over 6, well, I know that 180 is the same as pi, so pi over 6 is the same as 180 over 6, which is the equivalent of 30 degrees. So here I have that angle right there, pi over 6, right? This is 30 degrees. So this is an angle of pi over 6, 30 degrees away from the x-axis. And if I draw another angle 30 degrees from the x-axis here, that's an equivalent angle. 30 degrees on this side from the x-axis is equivalent. 30 degrees on this side from the x-axis is also equivalent. So now it's important that without even thinking, and we are not going to memorize these angles. We are not going to memorize them. We're not going to memorize the unit circle. We are just going to learn how to get these angles. But it's important that you know where all of the locations are. So what we do is the following. It's like a clock, right? So if this is 1 pi over 6, we start going up, right? 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and so on. What we want to do is we want to make sure that all of these angles here end up as a ratio of some pi over 6. So I never want that denominator of 6 to go away, right? So if I take 1 pi over 6, and if I increase the coefficient to 2 pi over 6, this reduces and the 6 as a denominator goes away. 3 pi over 6 also reduces. 4 pi over 6 also reduces. But the first one that doesn't reduce is 5 pi over 6. So that will be the next angle that corresponds to this. Now the next one, 6 pi over 6, is no good because it reduces. 7 pi over 6 does not reduce. 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6 is the other one that does not reduce. And so these four are the four angles around the circle that correspond to pi over 6. In each of the cases, over 6 stays. Okay. Now let's talk about pi over 4. Pi over 4 is equivalent to 180 over 4, which is 45 degrees. So here they are, right? 45, 45, 45. Okay, so the first one will be pi over 4. And again, we increase. 1 pi over 4, 2 pi over 4 reduces. 3 pi over 4 does not reduce. 4 pi over 4, 5 pi over 4 does not reduce. And the next one that doesn't reduce is 7 pi over 4, right? So if you write them out as a list, the ones that don't reduce are these. And then all of the other ones, the 4s reduce. So the point again is, if this says equivalent to pi over 4, all of the denominators should remain 4 because it's the same as pi over 4. So let's do pi over 3. Pi over 3 is equivalent to 180 degrees over 3, which is 60. So each of these angles are 60 degrees away from the x-axis, right? So if this is pi over 3, 1 pi over 3, 2 pi over 3 doesn't reduce, 3 pi over 3 does reduce, 4 pi over 3, 5 pi over 3. And if you go one more, 6 pi over 3, that's 2 pi. We just completed a circle. So these are the all of the different special angles around the triangle, around the circle. The one other one is called quadrantal angles. These are angles whose terminal side is either on the x or the y axis. So these are 0 degrees, 90 degrees, 180 degrees, 270, or 360. In radian, it's 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay? So remember, each corner is half a pi, half a pi, half a pi, 1 pi. 1 pi, half a pi, 1.5 pi, 2 pi. Okay. So putting it all together, right? If I put in my quadrantal angles in degrees, this is 0, 30, 45, 90, 60, and 90. So what you notice is the difference is you go up 30, up 15, up 15, up 30. Okay? So then 30 more will be 120, up 15, up 15, up 30. Okay? So again, it's a difference of 30, 15, 15, 30. It's tricky. Okay, difference of 30, 15, 15, 30. Okay? Okay, and honestly, the radian for me is so much easier, right? So look, 1 pi over 6, these are all the pi over 6s. 2, 3, 4, 5 pi over 6, 6, 7 pi over 6, 11 pi over 6. Okay, let's do the pi over 4s. Pi over 4, 2 pi over 4 doesn't work, 3 pi over 4, 4 pi over 4 doesn't work, 5 pi over 4, 6 pi doesn't work, 7 pi over 4 does. And if I wanted to do the pi over 3s, 1 pi over 3, 2 pi over 3, 3 pi over 3, no, 4 pi over 3, 5 pi over 3. Okay? Quadrantal angles, 0, all the way to the other side is pi, half a pi, here, 1.5 pi, 3 over 2 pi. Okay? There we have it. And of course, 2 pi. Beautiful. I mean, and then again, like all of the pi over 4s are the ones that end in 5, right? So that's another thing we can notice. Right. Let's talk about general angles. Right. So suppose you have a point, 3, 4. Okay? Now, suppose you draw an arrow from the origin to that point. To get to that point, you would have to go horizontally a little bit and vertically a little bit, right? Horizontally, you would have to go 3. Vertically, you would have to go 4. Now, by doing this, we created an angle right over here. Why don't we name that theta? Now, when I name that theta, now I have a triangle. Is it possible to find that purple side? Yeah, Pythagorean theorem, right? 3 squared plus 4 squared equals that squared. We're going to call this one R. In math, usually whenever there is an arrow from the origin to a point, it's always called R for radius. And that number will be 5. So now, now that we have this, is it possible to find the sine of theta using SOHCAHTOA? Yeah, that's opposite over hypotenuse, 4 over 5. But what's that for? Hey, that's just the y value, right? Over r. Okay, can I find the cosine of theta? Yeah, that's adjacent over hypotenuse, 3 over 5. But that 3 is just the x-coordinate over r. Tangent of theta is opposite over adjacent, 4 over 3, but that's just y over x. So notice, I don't even need a triangle. All I need is x, y, and this that I can find. And I can find, the trig functions using these formulas and their reciprocals. Okay? So why don't we go ahead and do that here? The terminal side of theta in standard position contains the point -3, 4. I label this x and y. To find r, right, it's going to be the Pythagorean theorem. So it's basically going to be the square root of -3 squared plus 4 squared. So r is 5. Okay. So sine of theta is always the y-coordinate over r. Cosine is the x-coordinate over r. Tangent, y over x. And now cosecant is the reciprocal. Secant is the reciprocal. Cotangent is the reciprocal. Okay? There we have it. All right, let's talk about a reference angle. This is something kind of unrelated. If you have any angle, the reference angle is an acute angle formed between the terminal side and the x-axis. So if you have an angle here, this is the terminal side. The angle between that and the x-axis is your reference angle. If this is your angle, now here is your terminal side, right here. The acute angle, so the angle between the terminal side and the nearest x-axis, right there, that is your reference angle. Now reference angle, if angle is theta, reference angle is theta prime. With an accent, it's called theta prime. So suppose this angle here was 60 degrees, right? How much would that yellow angle be? To go all the way from 0 to there, it's 180. And if the blue one is 160, that's the balance, 20 degrees. Okay? All right, take a look at this one. Suppose this angle here was, 210 degrees. Now the reference angle is the angle between the terminal side and the nearest x-axis. Okay? So this much is 180, and that yellow must be 30. So theta prime is 30. That's how you make 210. All right, same here. Suppose this is 300 degrees. This is the reference angle. So theta prime, the full circle would have been 360, but we stopped short by 60 degrees. So that's your theta prime. Okay. So let's sketch each of these angles and give the reference angle in degrees. All right. 330. Start here. 330 is going to go right there. This is theta prime. It's 30 degrees. Okay, negative 800. Right, so that's going to take us a while, right? So I go one circle, but that's not enough. I have to do another circle. Now I went 720. And the balance will be, after 720, 80 more degrees, right? So that theta prime is 80 degrees. Right, fabulous. Now, in the case of radian, it's actually much more straightforward, right? So if your angle, like we're going to be dealing with the special angles. So if you have your angle in reduced form, then the reference angle is just pi over that denominator. It's super straightforward. So for example, look at this one, 4 pi over 3. The reference angle, you could just do it blindly, is just pi over that denominator. Now 10 pi over 8 is not reduced, but if you reduce it, it'll be 5 pi over 4, and the reference angle will just be pi over that same denominator, 4. Right, so let's do a couple here. So in this case, when we reduce, this is negative 5 pi over 6. So let's sketch this. Okay, 5 pi over 6, we're going to go this way, right? So the first one is 1 pi over 6. 2, 3, 4, 5 pi over 6 is right here. Okay? Now the reference angle, I don't even need to think about it. It's just pi over that same denominator. Okay? Okay, 13 pi over 3. I'm going to skip the sketching. I'm just going to do we're going to do more sketching next time. The reference angle is just pi over 3. Okay, this one. For these, we're going to find the corresponding reference angle and state the quadrant in which the angle is located. And for this one, there's no like order which one you do first. The whole process is like, it kind of like all happens together, right? So let's see. 500 degrees, right? We start here. We go 360. And now I need to go 140 more. Right there. So that's 500 degrees. So we know that that's in quadrant 2. Now, what about the reference angle? Well, remember I went 140 that way? So this is just the remaining 40. Negative 2 pi over 3. See, in this case, reference angle is so easy. It's pi over 3. But to draw negative 2 pi over 3, okay, so 1 pi over 3, 2 pi over 3, this one. Okay? So it's in quadrant 3. Okay, now, all this is so we could do this for any and all angles, right? So if I were to give you like, I don't know, sine of, 57 pi over 6, you should be able to just do it, right? So there is a process. First, we want to find the reference angle. Then we're going to evaluate the function at the reference angle. Then we're going to determine the SIGN sign, if it's positive or negative. So let's go one by one. All right, so here, 240 degrees, right? Well, let's see where that is. 240 degrees is here. Okay? Now, the reference angle here, 60 degrees. So what we want to do is, we want to find cosine of 60 degrees. Remember we had like those cute little triangles before? Remember how I said you should be able to draw one at any moment, right? So 1, root 3, and 2. So now the cosine of 60 is adjacent over hypotenuse 1/2. But now what we need to do is figure out if it's positive or negative. So there's a mnemonic device that says all students take calculus. That's the formal saying of it. But that's not a true statement, right? Because not all students take calculus. So I've changed it. And so I say all students take classes. So here we go. It's like this. All students take classes. But why does this matter? It matters because whenever an angle falls in this quadrant, all of the functions are positive there. Sine, cosine, tangent, everything is positive. When an angle is in this quadrant, only sine is positive. In this quadrant, only tangent is positive. In the last quadrant, only cosine is positive. So now we are in this quadrant where tangent is positive. But if you're looking for the cosine, that's not tangent, so it'll be negative. So it'll be negative 1/2. So let's do the next one. Cosecant of 5 pi over 6. Right, so where is 5 pi over 6? Right there. Now, 5 pi over 6, remember that's the pi over 6? That's like the 30-degree angle. Anyways, theta prime is pi over 6. Like I said, that's like the 30-degree angle. So what I want is to find cosecant of pi over 6. That's the same as cosecant of 30 degrees. So when I go here, cosecant of 30, that's hypotenuse over opposite. In this quadrant, this is all students. Sine is positive, so is cosecant. So this is positive 2. All right, next one. Sine of 135. So here we go. $135 is over here. Reference angle is 45. So I'll tell you a secret. The ones that end in 5, right, those are the 45 degrees. So the reference angle is going to be 45 degrees. Okay, what we need to find is now sine of 45. But we know how much that is because it's 1 root 2. So sine of 45 is opposite over hypotenuse 1 over root 2 over 2. And in this quadrant, all students take calculus. Sine is positive. So here we go. Okay, so this one is cotangent 7 pi over 3, right? Now, 7 pi over 3 is 7 over 3 pi. And that's 2 1/3 pi. So if I want to draw that, it'll be, right, here's the initial side, 2 pi, and then 1/3 pi. So it's in the first quadrant. Now the reference angle is pi over 3, which is like 60 degrees. And so if I go on my triangle, the cotangent of 60 degrees is adjacent, let me write pi over 3, adjacent over opposite, 1 over root 3, which is root 3 over 3. In this quadrant, remember we said all are positive, so this will just be positive root 3 over 3. Okay, I'm going to actually skip over these and we're going to go to the quadrantal angles. Now, if your angle is a quadrantal angle and it falls on, one of the axes, then what you want to do is you want to use the coordinates and you want to do it like the first page of section 3. So for example, if your angle is 0 degrees, you're here. Remember how we said over here that we had for each coordinate, we had the x coordinate, the y coordinate, and the radius, which was the distance from the origin to the point? Well, here, let's suppose the distance from the origin to the point is r. In that case, that coordinate point is r, 0. And if I'm at 90 degrees or pi over 2, this coordinate, if this is a distance of r, that coordinate is 0, comma r. And if I'm at 180 degrees or pi, and this is r, then that coordinate is negative r0. And this one at 270 or 3 pi over 2 will have a coordinate of 0, negative r. So given all this, let's now find the trig values of the quadrantal angles. So here for each of them, we are going to use the coordinate points. Okay, so for 0 degrees, we just said the coordinate point is r comma 0. So if sine of 0, if it's y over r, then that's 0 over r, which is 0. If cosine is x over r, well, x here is r over r, which is 1. Tangent is y over x, 0 over r, which is 0. Now, cosecant is going to be 1 over 0, undefined. Secant is going to be 1 over 1. Cotangent, 1 over 0, undefined. All right, next. For 90 or pi over 2, the coordinate now is going to be 0, comma r. So 0 is x, y is r. So sine, if it's y over r, it's going to be r over r, 1. Cosine is x over r, 0 over r, 0. Tangent is r over 0, right? It's y over x, r over 0, undefined. Cosecant, 1 over 1, 1. Secant, 1 over 0, undefined. Okay, cotangent, it's not going to be 1 over undefined, right? So we're going to do the reciprocal of this, 0 over r, 0. So for the 180 degrees, my coordinate was negative r comma 0. And here might be a good idea to pause and just do this column on your own and double check what I'm going to get, right? So go ahead and do that. So hopefully you did pause. Sine was y over r. Cosine was x over r. Tangent, y over x, 0. So now, cosecant, 1 over sine, undefined. Secant, 1 over cosine. Cotangent, 1 over tangent, undefined. Lastly, 270. Again, why don't you pause and do this one and then come back and check. So y over r will be negative 1. Cosine x over r. Tangent cosecant, secant, cotangent. All right? What you notice, all of the answers here are either going to be 0, negative 1, 1, or undefined, right? Nothing else. Negative 1, 1, 0, or undefined. Okay, so we are going to stop here. And if you can, your homework is going to be the 12.3 worksheet. And if you see on your lesson plan, I actually have a review day planned before the quiz. But that review day isn't just like, okay, here is a review sheet, work on your own. No, we're actually going to go, mad crazy and just do, this stuff over and over and over again until you are feeling very, very confident. Because this is a very, very big concept. So again, make sure that you really stick to the way I'm teaching this stuff, as opposed to, hints or suggestions that you may get from others. Remember, I'm from your future, so I know what's coming for you, and I'm doing these with all that in mind. All right, have a good day. Bye bye.